Okay, let's examine our data now. We looked at, in the first experiment, the relationship between volume and pressure. And you recall I was successively decreasing the volume of the syringe. I started out at 20 cc's and gradually worked my way down to 10 cc's in 1 cc increments. And let's take a look at what happens. As I decrease the volume, notice the pressure is increasing. As I decrease the volume, the pressure is increasing. As one goes down, the other goes up. We call that an indirect relationship. And this is essentially the same experimental data that was obtained by Charles Boyle in 1660. In other words, volume and pressure are inversely related. The volume and the pressure are inversely related. Now, another interesting aspect of this data is that when I take the volume and the pressure in any situation and I multiply them together, I get a number. But that number remains constant or almost constant no matter what the volume and the pressure is. In other words, volume and pressure are related in such a way that when I multiply the volume in one situation and the pressure in that situation by another volume and another pressure, I get a constant. We call that an inverse relationship. So Boyle's law is then P1 times V1 is equal to P2 times V2. Again, the pressure and volume, the product of the pressure and the volume in one situation is equal to the pressure times the volume in the second situation, and so on, and that's equal to a constant. Now let's talk a little bit about why that happens. Let's kind of think of this at the molecular level. We had a gas that was in a syringe, 20 cc's of that gas, and at 20 cc's of that gas, the particles of that gas were relatively far apart in the syringe. They were moving around, banging into each other, banging into the walls of the syringe, and banging into the sensor, but they were relatively far apart. But as I decreased the volume, 1 cc at a time, those particles, the same particles, because it's the same gas, are getting much, much closer together. And they're hitting the sides of the walls much more frequently, with much more vigor. And that causes an increase in pressure. So we can explain that increase in pressure for the decrease in volume in terms of the diminishing amount of space that is allowed between the particles as I began to close that syringe. That as I began to shut that syringe down, I was closing the gaps between those particles. A process known as, or a feature of gases called compressibility. So that's Boyle's law then. And once again, it's the relationship between pressure and volume, and we now know it's an inverse relationship. Let's look at the second data experiment. And that was the relationship between temperature and pressure. A much different story here. This time we went from cold water to lukewarm water or room temperature water to hot water. And what we see here is we don't see an indirect relationship. We see a very direct relationship. In fact, it's so direct I could almost draw a straight line through this data. I could almost draw a straight line through these 3 points. And if I continued on, if I extrapolated out or even interpolated between these 2 points or these 2 points, I would see that all the points fall on roughly the same line. That's not an indirect relationship. That is a direct relationship, the relationship between temperature and pressure. And that's the same relationship, that result is the same result that Gay-Lussac discovered in 1789 when he said that P1 over T1 is equal to P2 over T2. The pressure over the temperature in one situation is equal to the pressure over the temperature in a second situation. That is a direct relationship. Let's explain that in terms of what we know about gases. Well, we know as we go from ice cold water, or we go from ice cold gas, I should say, or gas in ice cold water, to room temperature gas, to hot gas, that as we increase the temperature, we are increasing the average kinetic energy. That's part of the kinetic molecular theory of gases. As we increase the temperature, we are slowly increasing the average kinetic energy. If we increase the average kinetic energy, then we're increasing the force with which those particles are banging into each other and banging into the sides of the container, registering a higher pressure on the pressure sensor. So, in summary then, we've looked at 2 laws. Boyle's law, which we see is an inverse relationship between pressure and volume, and we see that the Gay-Lussac's law is the direct relationship between pressure and temperature.